up. You must be familiar with such a situation. Do you know how to insert batteries in a torch? Can you make out whether the switch of the torch is working properly? Can you determine whether the bulb in the torch is fused? You have learnt already previous classes about this. Let us learn about static electricity and various electrical circuits. Static electricity. Take a balloon, inflate it and tie up the open end. Now, cut a paper into small pieces and place them on the floor. Rub the balloon with a paper and bring the balloon near the pieces of papers. What happens now? Are the bits of paper pulled toward the balloon? Why does the balloon pull or attract the pieces of paper? We can say that when the balloon is rubbed with a paper, it acquires an electrostatic charge on its surface. The balloon is now said to be a charged body. When it is brought to near the bits of paper, the pieces acquire opposite charge and will rise and cling to the balloon. The force exerted by a charged body on another charged body is known as static electricity. Magnetic induction. Take a safety pin and bring it close to a ball pin. Does it attract the pin? Why? Bring the safety pin close to one pole of a bar magnet and see how it gets attached to the magnet. Now, bring an ball pin and touch it to the safety pin as shown below. Does safety pin attract the ball pin? Why? In above two cases, we notice that the safety pin acts as a magnet when it is in contact with another magnet. Magnetic property is induced in safety pin due to the bar magnet. Magnetic property possessed by a magnetic substance due to the presence of a magnetic near it. It is called magnetic induction. If the safety pin is not in contact with the bar magnet, can it attract the ball pin? What happens if we place the bar magnet very close to the safety pin but not touching it? Let us find out. Take a bar magnet in one hand and a safety pin in the other hand. Hold them in such a way that they are close to each other but not in contact as shown in figure. Ask your friend to bring an ball pin and touch the safety pin. You will notice that the pin will stick to the safety pin. Magnetic induction is when a magnetic material is close to a magnet and it also shows a magnetic property. Battery working. Take the help of your teacher to open a dry cell. What can you see inside it? Observe the chemical components in the dry cell. Inside a dry cell, there are certain chemicals which react with one another to produce electric energy. A dry cell consists of a container made up of zinc metal. The container also serves as the negative terminal in the center. A carbon or graphite rod with metal cap serves as a positive terminal. The carbon rod is surrounded by a mixture of carbon particles and a chemical called ammonium chloride. The cell is sealed from the top. The dry cell can supply electric current in a circuit for a certain time. After that, its chemicals get exhausted and it cannot be used anymore. Symbols of electric components. Do you know about symbols? How do you indicate to your teacher that you wish to go out to drink water? You know the signs for addition, subtraction, multiplication and division. You might have used the symbols for greater than, less than, equal to, etc. Symbols play an important role in our life. They convey precise meaning with few descriptions. Some common electric components can be represented by standard symbols as shown in the following: serial number, electric component, symbol, description and use. 1. Cell, cell symbol. The longer vertical line denotes the positive terminal and the thicker shorter line denotes the negative terminal. Second, electric bulb. Electric bulb symbol. Electric bulb is in off position. Third, switch on position. Symbol. Switch is a device used to open or close a circuit. 4. Switch off position. Switch off symbol. Switch is also called a key. Switch is open. Fifth, electric bulb is on. Electric bulb on symbol. Electric bulb is in on position. 6. Battery. Battery symbol. Two or more cells joined together forms a battery. 7. Fuse. Fuse symbol. Fuse is a safety device used in electric circuit. Simple circuit. In the previous class, you have learnt about some simple circuits. Let us learn a little more about them by performing a few experiments. Look at figure. A bulb, battery and switch are connected as shown. Can we make this drawing simpler using symbols? The picture of circuit using symbols is called a circuit diagram. Normal electric circuit. The series is connected with cell or battery, electrical conductive wires, electric bulb, switches. Different parts of the circuit: battery, metal wire, bulb and switch. Mode of connection. attach the switch to the battery positive terminal. The second terminal of switch should be connected to one terminal of the bulb. The second terminal of the bulb should be connected to the battery's negative terminal. If the switch is applied, the current flows in the circuit. The circuit is completed when switched. This means that the battery is combined with the positive pole to negative pole. It is called a closed circuit. It is said that electricity flows in the circuit. When the switch is stopped, the circuit opens. This means that the relationship between the battery positive pole and the negative pole is broken. It is called an open circuit. Observe how the battery and switch are arranged in the circuit. The sequence of components is as follows: positive terminal of the cell, wire, switch, wire, bulb, wire, negative terminal of the cell. Is it compulsory to follow the above sequence? Can you change the sequence and still make the circuit work? Try this experiment and write other possible sequences. Series circuits. In a series circuit, electricity has only one path to flow through. All the electrical components are connected in this path. If any one of them is removed or is not functioning properly, the circuit will be incomplete. Parallel circuits. A parallel circuit has more than one path for the flow of electricity. Each bulb in the circuit is connected in a separate path through which electricity can flow. If any one of the bulbs removed, the current flows continuously in parallel circuit. Connecting electric bulbs in series. Collect 3 torch light bulbs. Connect in series as shown in figure. Connect this to a dry cell. Observe the brightness of each of the 3 bulbs. Now connect one more dry cell in series with the first cell. Observe the brightness of each of the bulb. Then connect one more dry cell in series with the first 2 cells. Again observe the bulbs. Disconnect one of the 3 bulbs from circuit. What do you observe? In series connection of bulbs, if one bulb get fused, all the other bulbs in the series will stop glowing. It means that if one bulb is disconnected, the other bulbs do not glow. This can be observed in series bulbs used in a decorative items at the time of marriage and other festivals. Connecting bulbs in parallel. Take 3 torchlight bulbs. Connect 3 bulbs in parallel as shown in figure. That is, one end of each of the 3 bulbs are connected to one wire. The other ends of 3 bulbs are connected to another wire. These 2 wires are connected to a cell. Have you noticed that bulbs glow in dimly? Now disconnected one of the bulbs. It means that if one bulb is disconnected, the other bulbs continue to glow. This can be observed in our household electric circuit. All components in our houses are connected in parallel. Heating effects of electric current. The bulb becomes hot when you put it on for some time. What do you think this happens? It is the filament of the bulb that heats up due to current flowing through it. You might have seen an electric cooker, electric heater and electric iron. Are they also a filament to warm up? All these contains a coil of wire made up of nichrome. This coil is called filament of the appliance. You might have noticed that when these appliances are switched on, their flame filaments become red hot and give out heat. Does the filament in the bulb release the same amount of heat in the electric heater? The amount of heat produced in a wire depends on its material, length and thickness. Thus, for different requirements, the wires of different materials, lengths and thickness are used. The wire used for making electric circuits do not normally become hot. On the other hand, the elements of some electric appliance become so hot that they are easily visible. The filament of an electric bulb gets heated to such a high temperature that it starts glowing and giving out light. Can you think of some electric appliances that get heated up just like a bulb when electric current passes through them? Conductors and insulators. Let us identify electrical conductors and insulators. Take an electric circuit. Remove the pin between A and B as shown in the figure. Insert different objects like a safety pin, pencil, eraser, plastic, scale, mastic, piece of a glass metal bangle, piece of a glass bangle, paper clip, salt water, lemon juice, etc. in the gap between A and B. With each insertion, check whether the bulb glows or not. Record your observations in the table for each case. Pencil. Bulb glows. Rubber. Bulb not glows. Plastic scale. Bulb not glows. Matchstick. Bulb not glows. piece of a metal bangle. Bulb glows, piece of a glass bangle. Bulb not glows. Paper clip, bulb glows. Salt water, bulb glows. Lemon juice, bulb glows. If you look at table after recording your observations, you will find that the bulb glows in some cases and does not glow in other cases. Can you guess the reason? Substances which allow electric current to flow through them are known as conductors of electricity. Substances which do not allow electric current to flow through them are known as insulators. Key points: 1. When objects are rubbed together, they get an electric charge. This charge is called static electricity. 2. Magnetic property possessed by a magnetic substance due to the presence of a magnet near it is called magnetic induction. 3. The cell has a metal vessel made of zinc. It acts as a negative pole. A metal leaded carbon or graphite rod in the center of the cell acts as a positive pole. A variety of electrical devices are represented by their symbols. In a normal electric circuit, battery, switch and bulb are connected by series of electrical conductors. Connected the second terminal of a bulb in an electric circuit to the first terminal of the second bulb. If the circuit is completed, the bulbs are connected to the series. In an electric circuit, all the first terminals of bulbs are one joint bond and all the second terminals are one. If the circuit is completed together with the common point, the bulbs are connected in a parallel manner. The filament in the electric bulb begins to heat up to a high temperature and start lighting. Substances which allow electric current to flow through them are known as conductors of electricity. Substances which do not allow electric current to flow through them are known as insulators. Evaluation: 1. List out the required metal to conduct an activity to understand the static electricity and write the procedure. 2. How do you charge a balloon? 3. Dash is the positive terminal of the dry cell. 4. Dash device converts chemical energy into electric energy. 5. If a bulb is missing or broken in a series circuit, will the other bulb glows? Give reason. 6. If a bulb is missing or broken in a parallel circuit, will the other bulbs glow? Give reason. 7. How are bulbs in our houses connected? 8. Name some devices that run using heat effect of electric current. Okay children, I hope you understand this lesson. We will meet again with another lesson. Thank you.